This is lesson 51 of the Quantum Mechanics, a mini lecture series, Vectors Part 3. So in the previous video, I talked about unit vectors and the norm of a vector, so the length of a vector. And just a recap of what the norm or the length of a vector is. So length or norm is equal to the absolute value of the vector v, square root of the vector v hash dotted with vector v. And the asterisk here, the hash, means to take the real and positive or even zero part of the vector. Okay, and I'll give you an example. Suppose I've got this. Okay, a vector with two components, so in two dimensions. To find its norm, the first thing to do would be to find v hash, okay, v asterisk. Now v asterisk is just the negative, it's the reverse, if you wish, of the original vector. It's the negative. So let's take this. Let's take the dot product, that's what the dot here means, with the original vector. Take the square root. So we'll take the square root after. So we'll take the dot product first. 3i times 3i. So we're now doing expansion of parentheses, just as you would normally do in algebra. 3i times 3i. Okay, plus 3i times 4j. Minus, right now it's the 4j's turn. 4j times 3i. And then minus, because you've got minus plus here, minus 4j times 4j. Now I should also mention that with unit vectors, if you take the dot product, so technically speaking, this should be this, okay? It's really the same thing, same meaning, okay, same notation, I hat. When you take the dot product of the vector I hat with itself, you just get 1. And similarly, j with itself, you get j. If, however, you have something like this, you will get 0. Okay, in other words, I and j are two vectors that are at right angles. They're perpendicular to each other. Okay, so let's suppose I is running across the x-axis and j is running up across the y-axis. There are right angles, so therefore the dot product is 0. However, any vector along that same axis, you'll have a dot product of 1. That's what that means. That's what those statements mean here. And so these vectors, they have unit length as well. You can think of it this way. Unit length, okay, or unit norm. And so these vectors are also said to be orthonormal, another fancy way of saying that they're perpendicular and they have unit length 1, right? Orthonormal. So let's continue with the dot product. So 3i times 3i is just 9i. Okay, well, sorry, 9 times 1, because I times I is just 1. Okay, so 9 times 1 plus 3i. There should be a times here. 3i times 4j, that's 0. So you get 0 here. And then minus 4j times 3i, that's also 0. So you can see there's cancellation happening here. And then 4j times 4j, that's 16 times 1, right? Because j times j is just 1. Sorry, I should say j dotted with j is just 1. And so we're left with 9 plus 16, which is just 25. So that's the norm. That's the length of the vector. It's 25 units, I should say. Okay, that's how you take the dot product. That's how you find the length, the norm of a vector. Okay, that's the process. That's the series of steps you take to find it. Okay. So you find the vector asterisk, do the dot products, and you'll get an answer like this.